a video clip representing a problem from LeetCode with this problem's URL linked on the bottom of the page in yellow. You are a video developer, video game developer working on a collision physics for the game consisting of asteroids moving at the same speed. So these asteroids in size are represented by an integer array here. So you have 5, 10, -5. So -5 means, and these asteroids are moving on the same plane, okay, in 2D dimensions, either left or right, right? So you have some of those moving left, some of them moving right. So they're represented by the this integer array here. This is just an example, right? If the signs are different, so basically, if this is positive, that means the asteroid is moving right to the right. So 10 is also moving right, but the -5 means it is moving to the left. Now, these asteroids are moving at the same speed, and the number or the absolute value of each of these integers represent the asteroid size. So if we draw this out, this is 5, okay, moving in this direction. And then you have 10, right? 10, much larger in size. This one is also moving to the right direction. But the third one is -5, which means you have a asteroid the same size as the first one, but moving in opposite directions. So what's going to happen is, subject to these conditions, right? If two asteroids meet, meaning they are traveling in the opposite directions, the smaller one will explode, right? The smaller one of the two will be obliterated. But if they are the same size, then both of them gets obliterated, meaning nixed. The two asteroids moving the same direction will never meet. So what's happening is, what you end up with is number 5 is going to be gone, because 5 and 10 collides, 10 survives, 5 disappears. So what you end up with is 5, 10, right? So as you can see here, you're given an array of integers representing these asteroids traveling at the same speed but are of different sizes. Your end goal is to compute the end result of the asteroids. So this is the end result we're talking about for this examples, right? So let's look at some of the other examples here. So for example, like this one, we have 3 asteroids. One of them is 5 and -10, and then 5. We know 5 is going this direction, right, to the right. 10 is going left. So what's going to happen is, let me use a different color, is 10 is bigger than 5. So when 5 and 10 collides, then this is gone, right? So what you end up with is you have -10 and 5, right? And -10 is to its left, and 5 is still going to the right, and they basically never meet. So this is fine. This is the end state. Now let's look at the second examples here. We have 8, right, and -8. So this means that there's 2 asteroids of the same size traveling this in opposite direction. They're going to collide with each other. So we end up with an empty, right, array. The third one here. Now you have 10, -2, and then 5. So what's going to happen is 5 is going to go to the right, to the left, to the right. And 10 is to the right, and the -2 is to the left, right? So when you have 10 and then 2 colliding with each other, now the collision happens by examining, right, 2 objects, absolute values, right? So 2 and 10. So 2 is less than 10. So this one is going to be gone, right? So the end result, right, as you can see here, is if -2 is gone, then you're left with 10 and 5, right? So 10 and 5 is going to be the end result. So that's the second examples. Let's look at the very last one. I think after this is we're ready to code. When you have a whole bunch of these, this is tricky, right? A whole bunch of these asteroids are small, traveling to the right, and then you have this -2 traveling to the left. What's going to happen is, given the same condition, the first conditions here, 2 asteroids meet, the smaller one would explode, right? This means that all of these ones will explode one at a time, because the big one is going to succeed, right? Assuming after the collision, there's no size changes. So 2 remains 2, right? So smaller will be obliterated. So at the end, what you end up with is -2 and 5. Why is that? Well, 5 continues to go to the right, and left is going to continue to go to the left. And then, and what's happening here is all of these asteroids to the left of this -2 will then be obliterated, one at a time. So you end up with -2 and 5. Okay, so this is the problem, and let's begin the coding. We're given a solution method called asteroid collisions, and this one takes in an array of asteroids, as we described, collision is going to happen at some point. We're going to left with some collided results, and the end goal for this method is to return the end results. Since we're given an array of asteroids, right? So these asteroids are represented by by some numbers here. So whatever these numbers are, 1, maybe -1, so on and so forth. The way to solve this problem from an intuition standpoint is either we go through these asteroids from left to right directions, or we can go through these asteroids from from right to left directions, right? Either way. So for all intents and purposes, we can probably just iterate through these asteroids from left to right. Now, since we're going through this one at a time, and collision is going to happen, right? Which means at some point, when we march our pointers through from left to right, something might reconcile, and sometimes, right, depends on the size of the asteroids, we might have to go back, right? And basically remembering, what we came from. So this is sort of, right, similar to the concept of backtracking, right? So now we're talking about maintaining the history of the path, backtracking mainly, then this is a perfect solution for using a stack, right? So if you're gonna go and think about this whole thing, using a stack as we traverse through these entire array, right? So there's a stack that we can keep track of. So basically this entire stack, right, last in, first out, will then be responsible for maintaining the end result. If there is nothing changed, then the stack's going to keep on growing, so on and so forth. At the end, we'll have to convert, right, this entire stack, which is last in, first out, to an array, right? So what is an array? This is a collection, right? This is first in, first out, right? Array is kind of like that. So we're going to have to, because array starts with 0, right? 1, 2, 3, 4, 5. So in order to convert this back into a fivefold, that's the end result. And that's what this is what we are going to return, integer array. Okay, so let's start. If you're going to use an array for this part, we can do, let's just make sure that we import the right library, which is stack. Now, since we're going to be running some tests here and print the results, which is an array, we may want to use something like this. So let's just do a system out print line first. Make sure that we have this entire thing set up. Solution is going to call asteroid collisions, and this asteroid collision is a new integer with, let's just say, we just make up some value, let's say by -10. In this case, the end result is going to be 5, right? Because -10 and 5 will be collect, and 5 and 10 is bigger than 5. So that's the end result. Now we can just print this, because then you'll print out the memory location of this array. So what we want to do is, what we can do is use array toString. This array toString will print out the entire array in a pre-format. So we have to also import Java util arrays. Okay. All right, let's make sure that this compiles. Okay, so this compiles. Let's move on to the logic here, right? So since we're going to be using an array, so let's just create this, not array, the stack. Let's just create an integer stack, because these array, this stack consists of array of integers. Stack, like so. So first thing we want to do is to write a for loop, right? Basically iterating through all of the asteroids, right? So what's going to happen is that there are a couple of use cases we consider. Now, if let's say if all of the asteroids are moving towards the right, there's obviously no collisions here. The collision only happens when we come across these asteroids, right? The current value versus whatever is there. They are traveling in different directions. Now, if they're traveling in different directions, there are 3 scenarios, right? So let's just set up this whole thing here. Now, what we want to do is going through this entire stack, right? As we traverse through these things, we want to go through our backtracking stack and making sure that if the stack is not empty, we can kind of peek into what was before, right? So that's the very first thing. Now, we are only interested, right, in the internal traversal, meaning collision resolutions, when there's value in the stack, and the value happens to be A, which is the incoming asteroid, right? The very next one is less than, right, 0. So this gives us the fact that this one is traveling to the left, while the previous one traveling to the right. So what was the previous one? The previous one, remember, stack is used for backtracking, right? Is greater than 0. So I hope this makes sense. This means that the incoming asteroid, which is the current asteroid that we're looking at here, is in a different directions of where the last one was. So only when stack was empty, you take a peek at the previous one. If the previous one is greater than 0, and the current is less than 0, that means there is a collision oncoming. So there are 3 conditions for this while loop. One of them is when the incoming asteroid, which is AI, and this is the A-1. So I-1 is whatever is inside the right stack. If this is when incoming is greater than, equal to, or less than, right? So for the very first one, if incoming one is much bigger than the older one, right, it's going to explode. And this is going to continue. Why? Because the incoming one is going to keep on, checking on, right, all the way to the left to see if there's any more to explode, to basically take control over it, the whole situations. But for both second and third conditions, what happen is the incoming one is going to explode, basically gone, right? So you don't want to persist them in the stack. What would happen is the very first one is going to continue at some point. There could be a chance for it to come to a complete stop, and then you're going to want to stack push, right, this A right here. But you don't want to stack push A for second and third conditions, right? And that's a given. And also for the second condition, the previous one will also explode, right? But the third one will just leave the previous one, intact. So let's just move on with the logic here, in this while loop here. Okay. So let's just say the very first one is stack, right? So I'm just simply writing out the logic here. Stack peak is less than the absolute value of the incoming asteroid. In this case, then what we want to do is want to stat pop, right? And meanwhile, this asteroid would continue to flow left to continue to destroy, if possible, right, anything that is inside its path. So this while loop continues at that point. The second situation is when both are equal, right? When stack peak is the same size as the math, right, the absolute value of A in that case, then what will happen is you want to destroy both of them, right? So destroying both of them means the previous one will be destroyed by popping it off of the stack. And you don't want to do anything with this because A would have been destroyed, right? Here's an interesting, because we want to make sure that when this while loop is done with the first conditions, we also want to, at the end of this while loop, now we're in the for loop here. This is the while loop conditions, right? In this for loop, we want to be able to stack and push A here. Interesting thing is when this gets done, well, this is the case because we're breaking it, right? There's nothing more to go because they both destroyed. We want to do a stack push. So what we want to do is set up a flag. So maybe, for this condition, we want to push, but for these and the other condition, which is really the break. What is the third one? Third one, this is less than that, right? Because since we're already checking for the first two, the third one is really the else condition. So we don't have to write the else in that case. We can just break it. But you don't have to break it twice, right? You can just break it all at once. So the flow of logic is actually going to flow for the second condition down to the third, and the third one is break as well. So for this one and this one, right? Second and third conditions, we don't want to push A into the stack, right? So what we can do is we can set up a Boolean here. Let's say this Boolean is intact, right? This is the Boolean for whether the asteroid is intact or not. In the beginning, it's true, right? So for this one, it's true, but for this one, it's false. So is the third one. So we can say is intact, right? Equals false at this point. And then we will want to only push A into the stack if A is intact. So writing a quick one, outside of the while loop now, right? Let's just move this up. If is intact equals true, right? Or you can say is intact, it's the same thing. We will stack push this in, okay? Now this completes this logic. Let's just make sure that this thing will compile. So you gotta make sure, keep checking syntax is correct or not, because you don't wanna fix the whole thing at the end, which is a lot more work. Now, this is not done because we have to convert our stack into our integer, right? So stack is last in, first out, and our integer array is almost like a queue. It's a first in, first out, right? So in order to translate what is in the LIFO, right? Because we pop on the least, right, for the very last element. We have to convert it into a array indexing 0 base array. So what we can do is we can create what we need to return, which is an integer ret value, return value, right, which is an array of integer, and this is of size, stack size, right? So this is the whole thing. We're dynamically instantiating an integer array, and then we want to write a loop here. And this loop starts from the back because the very first element that gets popped is at the back of your stack, right? Which is all the way at the end of your read val, right? Return value. So this is our stack size, right? Or you can say this is our ret val length, right? Actually -1, right? Because we array indexing is length -1. So I greater than equal to, right, 0, and then minus I. So we are effectively just looping it all the way from the back to the front, right? Okay, so this is what we're gonna do. We're gonna write read val, right? This is I equals to stack pop. Okay, so this allows us to pop every single one of these elements, push them into the back of our ret val one at a time. So our entire loop goes from the back to the front. This would allow us to basically mapping all of the elements inside the stack into the return val, right? So let's just push this. We got our test cases set already, and our test cases is 5 and -10, right? Of course, 10 is bigger than 5, so it's going to obliterate. So you get -10 at the end. So if we're going to push this, let's say 1, 1. So let's just create another use case. In this case, we're going to put 100 at the end, right? So at the end, -10 is going to keep on eating up, right? Moving to the left, eating up all these ones. At some point, we're going to have a head-on collisions. -10 is then going to be collided with 100. And in that case, 100 is going to win out, and then we get 100 left. So let's just move on with the test. As you can see here, the first one is -10, the second one is 10. So this is the correct solutions. Let's look at time in space complexity here. So in terms of time complexity, we have n number of asteroids, right? There's n number of them. So the fact that we have to go through every single one of them, this time is O of n, right? Now, what about space? Well, worst case scenario is we have at the end, right, this amount of space to keep track of our return value. So this is a number of them, right? So this gives you a number of them. So worst case is O of n as well. So space and time, both O of n for this solution.